Welcome. In the previous video, we implemented a bare-bones string view data structure, and in this one, we're going to extend it with extra functionality. We can begin by defining the SV literal macro that is going to help us test the functions that we are going to create. And we can begin by creating the SV equals function. For that, we are going to need to include stdpool. After including stdpool, we can now create the body of SV equals. We can initially check if both string views have the same amount of elements. If not, we return false. And then we use the memCompare function to test if both of the string views data have the same characters. To use it, we need to include string.age. Now we can test if our implementation is correct. To do that, we can, for now, comment the following code. Having this code commented out, we can now add a string view A and a string view B declaration. Both are equal using the SV literal macro, and then we can print out the result. If we run the code, we can see that SV equals AP equals to 1. If we add a third string view called C, that is just hello, and then test if A is equal to C, we'll get the result 0 or false. Now we can move on and implement the SV as prefix function. To do that, we can begin by testing if the provided string view counts as less elements than the prefix we are trying to test. If that is not the case, we can just take the substring from the provided string view and then use the function we just created, SV equals, to test if the substring is equal to the prefix. If we now get the result from SV as prefix AC, we should get 1. Do not forget that we actually do not need the reference to SV since we are not modifying it. If we run the program, you'll see that this is not a prefix. That's because we have a new line at the end of hello. If we remove the new line from the string view C, then we'll get to adding a string view D and then testing for a prefix. We'll get false, as you can see. Let's move on to the next function called svShop that is going to shop an amount of characters from the string view that was provided by the user. We begin by making sure that n is not larger than the count of the string view. Then we temporarily store the result. We update the string view. And finally, return the result. To test this new function, we are going to need the following code. First, we are going to store the shopped value into this taken variable that is of type string view. Then we are going to print it, and then we print the updated value of A. If we run the code, we'll be able to see that SV shop A1 is equal to age, and then A is updated to the value without the initial age. We can obviously update this 1, 2, 3, and then the result would be age EL, and then A would be updated to the value LO, and then the rest. We can now implement the last function of today, svShop prefix. To shop a string view by its prefix, we must begin by testing if the provided string view actually contains the prefix. If that is not the case, we then return an empty string view. If the provided string view actually contains a prefix, then we can just shop it by the prefix count. Finally, we can test this by updating our taken variable with a function called svShop_prefix to B using the C. So we are going to shop hello world using the string hello. Then we print it, and then we print the updated value of B. Running the run script once again, you'll be able to see that svShop prefix of hello world is hello. B is now updated with the value comma space world. And this is how we were able to extend our string view data structure with some minimal functionality. In the next episode, we are going to introduce predicates to it.